Hey everyone, today we are going to crack the code on a math problem that can feel, a little tricky. Dividing fractions. But I promise, by the end of this, you're going to have a secret weapon to solve them. Every single time. So, does looking at a problem like this ever make your brain feel like it's tying itself in a knot? Yeah, if you said yes, you are definitely not alone. It can look super confusing, but I'm going to show you a way to solve it that is so much easier than it looks. I mean, what if I told you there's a simple, almost magical three-step trick that gets you the right answer every single time? Get ready, because you are about to become a fraction dividing pro. Okay, let's dive right in. The secret is this simple little phrase you can remember, kind of like a cool chant. It's called keep, switch, flip. This powerful little phrase, well, it's the key that unlocks the whole thing. So how does it work? It's really as simple as it sounds. First, you keep the first fraction exactly as it is. Don't touch it, don't change a thing. Second, you switch that division sign to its friendly opposite, multiplication. And third, you flip the second fraction. You literally turn it upside down. All right, enough talk. The best way to learn this stuff is by actually doing it. So let's put our keep, switch, flip rule into action with a real example and solve it together step by step. Okay, here's our problem. 2/5 divided by 3/10. Let's use our rule. First, we keep the 2/5. Next, we switch the division sign to a multiplication sign. And finally, we flip the 3/10 so it becomes 10/3. And just like that, our tricky division problem is now a way friendlier multiplication problem. Now hang on. Before we multiply, here's a pro tip that makes life even easier. See if you can simplify. If you look at the numbers diagonally, we've got a 10 on top and a 5 on the bottom. We can divide both of those by 5. So the 10 becomes a 2 and the 5 becomes a 1. See? This is going to make our next step way simpler. Now we just multiply our new simplified numbers straight across. So on top, 2 times 2 is 4, and on the bottom, 1 times 3 is 3. So our answer is 4/3. Awesome job! But wait a minute. Does something about that answer seem a little odd to you? Yeah, look at it. Doesn't that fraction look a little top-heavy? It should. The number on top, the numerator, is bigger than the number on the bottom, the denominator. So what does that mean? And what do we even do about it? Well, this is what we call an improper fraction. And no, it's not wrong or anything, so don't worry. It's just not the simplest, neatest way to write our final answer. We can tidy it up by turning it into something called a mixed number. That's a whole number with a proper fraction right next to it. And that brings us to our final step, tidying up the answer. Let's take our improper fraction and turn it into a nice, clean, mixed number. The tool we're going to use for this job is something you're probably already familiar with, good old long division. It's the perfect way to figure out how many whole numbers are kind of hiding inside our improper fraction. Okay, let's do it. We ask ourselves, how many times does the bottom number, 3, go into the top number, 4? Well, it fits in one whole time, right? Then we see what's left over. We know 1 times 3 is 3, and if we subtract that from 4, we have a remainder of 1. Now, check this out. Each piece from our division problem has a special place in our final answer. The main answer we got, which was 1, becomes our big whole number. The remainder, which was also 1, becomes the new top number, our new numerator. And the original bottom number, the denominator, it just stays the same. So the 3 stays a 3. Easy. And there you have it. Our improper fraction, 4/3, is now the neat and tidy mixed number, 1 and 1/3. And that is our final polished answer. Fantastic work. So the next time you see a fraction division problem, don't sweat it. Just remember that secret rule. Let's say it one more time together. Keep, switch, flip. It really is the key that makes the whole thing so much simpler. So now you have this awesome trick in your math toolkit. It kind of makes you wonder, doesn't it? Math is full of these cool patterns and secrets, just like this one. What other math secrets do you think are out there, just hiding in plain sight, waiting to be discovered?